Chloe Rash, the science girl. Chloe.
Chloe. Acids and bases.
Science rules. Good morning, students. Today we're going to be talking about acids and bases. The properties of acids are they have a sour taste, they react with metals to form H2 gases, they turn blue litmus paper red, the aqueous solutions of acids are electrolytes, and they react with bases to form salt and water. Now, the properties of bases is that they have bitter taste, they feel slippery to the touch, they do not react with metal, turns red litmus paper blue. Aqueous solutions of bases are electrolytes, and they react with acids to form salt and water. Yes.
So since limes are sour, does that make them an acid?
Yes. Yes.
What's an example of a base?
An example of a base would be NaOH, which is sodium hydroxide. So the next thing we're going to talk about is naming acids and naming bases.
Yay!
So there's binary acids and ternary acids, and when naming, you do two different things. When you're talking about binary acids, you begin with the hydro and use the root of the element name and the suffix "ic". An example of that would be hydrochloric acid, which is HCl. Now, ternary acids, you begin with a polyatomic ion without the suffix. You add suffix "ic" if there was an ate, or you add the suffix "ous" if there was an ite.
But how am I supposed to remember that?
Just remember, I took a bite and it was delicious, and I ate something icky. Now we're going to talk about strength. The strength of acids. Strong acids completely ionize, and weak acids do not completely ionize. Three strong binary acids are HCl, HBr, and HI. Now the strength of bases. Strong bases completely ionize in water. Weak bases ionize only slightly. Yes?
What's an Arrhenius base and an Arrhenius acid?
Alright, an Arrhenius acid must contain an H and dissociates in water to produce hydronium ion H3O+. An example of that would be HBr. Now for an Arrhenius base, it must contain an OH and dissociates in water to produce hydroxide ion OH. An example of that would be CaOH2. Now we're going to talk about the Bronsted-Lowry theory of acids and bases. The Bronsted-Lowry acid is the reactant that donates a proton, H+. The Bronsted-Lowry base is the reactant that accepts a proton, H+. An example of that would be this right here. Okay, class, this concludes our lesson over acids and bases. And always remember one thing, science rules.